Hi everyone, I hope you're excited about AP Calculus this year. I have created this summer packet to help you prepare for AP Calculus. It's my hopes that with this packet we'll be able to spend more time on the more difficult calculus concepts instead of reviewing all of the algebra that you should know already. I'm going to go ahead and start with section 1, fractional and negative exponents. I'm going to do some random examples throughout each section. If you have more questions, feel free to email me and I will answer the rest of your questions. All right, so let's start with number 1. It says simplify using only positive exponents. So I have negative 3x to the negative 3. So I can't have that negative 3 power. I need to somehow change that. All right, so I need to change it to a positive exponent. So I'm going to have, this is the same as negative 3 times 1 over x to the third. That's what x to the negative 3 is. So when I combine both of those, I get negative 3 all over x to the third power, and that's your answer. All right, things like number 3 might be a little bit more difficult. So number 3, I have 2, so think of it as 2 over 1, times 2 over 2 minus x, times negative 2 over 2 minus x squared. Now, one of my big pet peeves is when people just cancel the 2's, so please don't do that. All right. That's just like if we had 1 over 1 plus 3, you can't just cancel the 1's, right? Or 2 over 2 plus 3, we know that's 2/5, not 1/3, right? All right, so in this example, I'm going to multiply across the top. So 2 times 2 times negative 2 is negative 8. And then I have 1 2 minus x, and then I have 2 more 2 minus x's. So I'm going to write it as 2 minus x to the positive 3. And that's all you can do. All right, let's see. So I have, this one looks a little weird, number 5. So I have negative x to the negative 1/2, so that's a negative power. So a negative power means 1 over. In this case, so if I had x to the negative 1/2, I could write that as 1 over x to the positive 1/2. All right, so basically this whole term is going to go to the bottom and become positive. But we also know that a 1/2 power is a square root, so let's write it as a square root. So I'm going to have negative 1 over 2, and then I have my square root of x times sine of square root of x. So I would combine that all into 1, so it would be negative sine of the square root of x all over 2 times the square root of x. Now in AP Calc, I'm not going to have you guys waste your time a lot of times and get rid of the square root here on the denominator. That's called rationalizing the denominator. So you can leave it like that. Now another big thing to notice is that I have a square root of x on top and a square root of x on the bottom, but these actually don't cancel out. So a lot of people would just say, okay, I'm going to cancel those out and I just have negative sign all over 2. But you can't do that because the sign of something, that's called the argument. You always have the sign of a number, right? So you can't get rid of that number there. All right, this next one. Now this one's a little bit tricky. So I have the square root of 4x minus 16. And when you look at that, you're like, I can't really simplify that any. But you actually can, because that can be written as the square root of 4 and then times x minus 4 in parentheses, which you can actually break up into 2 pieces. So you can say it's the square root of 4 times the whole square root of x minus 4. Now on the bottom, I have a 4th root and a 3rd power. So that's going to be a rational exponent. It's going to have a fraction for an exponent. It's going to be x minus 4 to the 1 or to the 3 over 4. Now if you remember, a square root is a 1/2 power. So this x minus 4 under the root is going to be x minus 4 in parentheses raised to the 1/4 power. So I have my square root of 4, which is 2. Then I have x minus 4 to the 1/2 all over x minus 4 to the 3/4. And if you remember, if I had x squared over x to the 5th, in Algebra 2 and Pre-Calc and all of those classes, we always expanded and then canceled. Or we used something called the subtraction rule. So see, you have a power 2 and a power 5. That became x to the negative 3, or 1 over x cubed. So we're going to do the same thing here. So see how I have a 1/2 and a 3/4? I'm going to subtract the 2 things. So when I subtract them, 1/2 minus 3/4, or 0.5 minus 0.75, is negative 1/4, right? So I get 2 times x minus 4 to the negative 1/4 but we can't have negatives, so we have to have positive exponents. So it's going to be 2 all over x minus 4 to the 1/4. Now, I don't care if you leave it like this. That's actually the way I prefer. Or you could write it as 2 over the 4th root of x minus 4. And like I said, we don't have to rationalize in AP Calc, so you can leave it like that. All right, let's go to the next page. Okay, we got some other tricky ones. Now, number 7, we have a -3 power to start out with. So that -3 power, you can do it a couple different ways. You can bring the -3 into both pieces, and then you can do 1 over each piece and simplify from there. But if you remember, I always talked about if you have a -3 power, then flip the whole thing to begin with. So instead of 2x minus 1 being on the top, it's going to be on the bottom. And instead of 2x plus 1 being on the bottom, it's now going to be on the top. And now you're raising it to the +3. So that gets rid of that weird negative exponent to begin with. You just flip the whole, it's called the base, the whole base there, the whole thing. All right. Now I have a -4 out front. So think of it as -4 over 1. And then I'm going to go ahead and simplify this messy numerator. So when I simplify, I get 2 times 2x plus 1, so 4x plus 2. Then I have minus 4x, and then the negative distributes to the -1, so I have plus 2 there, all over 2x plus 1 squared. All right, keep simplifying. All right, my 4x minus my 4x, that goes away, so I just have 4 on the top. So these two things combine to be 4. So let me write it a little bit simpler. So I have -4 over 1 times, I have 2x plus 1 3 times, and 2x minus 1 3 times. I just distributed my 3, basically. The power goes to both the numerator and denominator. And I have 4 over 2x plus 1 squared. So if you notice, we have 2x plus 1 on the top and the bottom. So we can get rid of 2 of them. So 2 are gone, and then 2 are gone. So I just have 2x plus 1 on top. So my final simplified form is -16. So 4 times 4 times 2x plus 1 all over 2x minus 1 cubed. Okay, you can leave it like that, or you could distribute the -16. It doesn't matter. All right, this one's a fraction divided by a fraction, so I would probably rewrite. So you'd have 1/2 of 2x plus 5 to the -3 over 2, it looks like. I can't really see on mine. And then times, remember, if you're dividing by a fraction, you're multiplying by the reciprocal, so multiply by 2/3. And that will make it a little bit simpler because you cancel your 2's, but then remember you have this negative power, so you're going to have to take care of that. So finish that one out. All right, this next one, it's kind of a tricky one. It seems like you can simplify it more than you can, so we'll go ahead and do number 9 as well. I'm going to erase number 8 so I have more room. All right, so I have a -1/2 power. So a negative power means 1 over. So it's like you're taking this whole thing and you're doing 1 over it. So kind of weird. Let's go ahead and simplify it first on the inside. So if I have 1 over x to the -2, well, that's 1 over 1 over x squared, which is 1 divided by 1 over x squared. So all that is 1 times x squared over 1. So it just ends up being x squared. So this first little bit is just x squared. The next little bit is 4. X to the -1 is going to go to the top and become x to the +1. Y to the -1 is going to go to the top and become y to the +1. Plus, this last part is going to be y squared. All right, now it's all being raised to the -1/2 power. So a lot of people try to bring that -1/2 in, and that drives me crazy. You cannot do that. For the same reason, like if you have x plus y squared, this is not equal to x squared plus y squared. That always drives me crazy. I always call that the freshman dream. So it's what a lot of like freshman math students in college will do. All right, so you can't do that. Same reason you can't pull in this -1/2 power. So I'm going to do 1 over, and then a 1/2 power is a square root, x squared plus 4xy plus y squared. And then a lot of people actually think that that factors. You need x and x, and you need y and y, but there's no way to get that 4xy in the middle. So that's actually as far as it will go. So that's your answer. All right, let's try some domain problems. Okay, domain is affected by several different things, but mostly you look for square roots and denominators. I think I have one logarithm problem in this too. So, and logarithms. Okay, so basically you're finding what makes something undefined, what makes it not good. It doesn't, there's no way to like graph it on a t-table, right? You don't get a value out. So basically you're looking for when the denominator is equal to 0. So in this first one, it's real easy. You just say, okay, 4x plus 1, that can't be equal to 0. So you can write doesn't equal 0 or just say equals 0 and then remember that those are the bad points. All right, so subtract 1 over, divide by 4, you get x equals negative 1/4. So that's the point that's bad. It's not in the domain. So that means that we have the whole number line except at negative 1/4. We have everything shaded in except for that 1 point. So there's an open circle there. So the way I write it is in an interval notation. So I would write negative infinity to negative 1/4, parenthesis, union, parenthesis, negative 1/4 to infinity. So since it's a parenthesis in the middle, that means that you skip over negative 1/4 and you don't include it. If you wanted to include it, you would need a bracket. Right? You could also write this as all real numbers except for negative 1/4. So any way that you want to write this, personally I like interval notation, but a lot of people don't like it, so it's up to you. Okay, number 3, you're finding when the denominator can't be equal to 0. So you're saying x squared minus 3x minus 18 equals 0. Okay, you can use quadratic formula. I think the easiest thing to do is factor. So you need x and x, you need negative 6 and plus 3. So that means x equals 6 and x equals negative 3. Again, these are the bad points of your domain. So that means you're going to skip over negative 3, and you're going to skip over 6, and you're going to shade everything else. And it's kind of messy. So I'm going to have negative infinity to negative 3, parenthesis, union, negative 3 to 6, union, 6 to infinity. Or like I said, you could just say all real numbers except negative 3 and 6. All right, now square roots, that's the next thing that's weird. So think about what makes square roots bad. We can't take the square root of a negative number. So when I look at number 5, I know that x minus 3 has to be greater than or equal to 0. You can take the square root of 0. Square root of 0 is just 0. All right, you also have to consider that the other square root has to be positive under the root. So x plus 3 has to be positive. And then you solve both. So you get x has to be greater than or equal to 3, and x has to be greater than or equal to negative 3. Both things need to be true. So when you plug in negative 3 and 3, think about where both shadings are true. So we want greater than 3, and we want greater than negative 3. So try a number in between. Try 0. What happens when you plug in 0 into the first part? That's when you get the square root of negative 3. So that we can't do that. So 0 doesn't work. And that makes sense because it's not where both things are true. So both things are true where they overlap. So from 3 on. It can be equal to 3 because that would just give you 0 on the first one. So that's allowed. So it's bracket 3 to infinity. All right, number 6 involves a square root and a denominator, so that one's going to be kind of tricky. All right, next up. Okay, number 8's pretty difficult. I know x squared minus 5x minus 14 has to be greater than or equal to 0. Okay, we're actually going to do this in a later section, but let's go ahead and talk about it now. Okay, so when I factor, it's x minus 7 times x plus 2. So I get x equals 7 and x equals negative 2. Okay, these are the places where it's equal to 0. So we call these critical points. So I always graph the critical points on the number line, and then you have to use test points to see if each location is true or false. So you want to test a point on the left of -2, so like -3, in the middle of -2 and 7, so maybe like 0, and on the right of 7, so 8. Okay. And I usually do a little test table, but you don't really need the table. And you're testing it in your inequality, so the factored form. So you're testing it in x minus 7 times x plus 2 is greater than or equal to 0. Okay. Now we're only worried about when it's greater than or equal to 0, if that's going to be true or false. So greater than or equal to 0, that means we're looking for positive numbers. So when I plug in -3, I'd have -3 minus 7, so that's a negative number. -3 plus 2 is a negative number, and a negative times a negative is always positive. So does that make our inequality true? Yeah, it works. When I plug in 0, I get -7, positive 2, so positive. So a negative times positive is a negative. So that will make less than or equal to 0, right? So that wouldn't work. And then 8 gives me positive, positive, so positive number out. And that's what we wanted. We wanted positive numbers. So -3 worked, and any number on the left of -2 would work. 8 worked, any number on the right of 7 would work. We want greater than or equal to 0. Well, the critical points are what made it equal to 0, right? So we fill in. So your solution set is -infinity to -2, bracket, union, bracket, 7 to infinity, like that. All right, number 10. So I have log of something. Now, if you remember when we talked about logarithms way back in Algebra 2, you can't take the log of a negative number, and you can't take the log of 0. So you can try some different things on your calculator. That's definitely true. So basically, this whole part here, 2x minus 12, it's kind of like the denominator thing. Well, not the denominator thing, the square root thing. But with square roots, we said it had to be greater than or equal to 0, right? In this case, we're going to say it has to be greater than 0, because you can't take the log of 0 either. So greater than 0. So it must be positive. All right, solve it out. So add 12 to the other side, divide by 2. You get x is greater than 6. You can leave it like that. Or if you wanted interval notation, it would be 6 to infinity, everything in parentheses. All right, and then number 12, so I have cosine of x on the denominator, so I know that that cannot be equal to 0, so I want to find when it is equal to 0. So when is cosine of x equal to 0? Okay, and you might have forgotten this from pre-calc, but we're going to talk about it later. It's going to be in the unit circle section. So this is what I always use. I always use the unit circle. Any point along the unit circle, it's a distance of 1 from the origin. So this is 1, 0, 0, 1, -1, 0, and 0, -1. The x value is cosine. The y value is sine. And in AP Calculus, you're always going to use radian measure. You hardly ever use degrees. All right, so we want to know this is going to be 0. This would be pi over 2, pi, and 2 pi. Oh, what am I doing? Pi and 3 pi over 2. And then 0 is also 2 pi. So a lot of times it will say something like, find the solutions between 0 and 2 pi. In this case, I didn't say that, so we need to find all the solutions. So looking at our cosine and sine values, when is cosine equal to 0? It's equal to 0 here and here. So it's at pi over 2, 3 pi over 2. But then you could come back around, so add another pi. So you could have 5 pi over 2 and 7 pi over 2, right? So the easiest way to write this is x equals pi over 2 plus pi k. And k can be any integer. So you could actually have negative pi over 2, that's down here, or negative 3 pi over 2, so where k is an integer. Okay, so that's all you need to know about domain.